So the point of this video is to go over some questions on the quiz. And the first one we're going to look at is question 6. So if we go back. Um, so you need to be able to interpret the derivative, because in chapter 4 we're going to do some things with some graphs. So sketch the graph of the function for which the value of the function at 0 is 1. So I need to know that there's a point that is 0, that when I plug in 0 I get out 1. Then the function slope, this represents slope, so the slope at 0 is 0. And then this is saying the derivative is the slope, so the slope is greater than 0 if x is less than 0, or if x is greater than 0. So a few different kind of approaches here. These are what I have. I can do this. I can get this graph. If I don't want this graph, I can delete it. I can get this graph, or I can get a graph that looks like this. Right, so those are my kind of my four choices. It's kind of like multiple choice. So I need a one that has a negative slope on the left side of 0 and on the right side of 0. So I need a negative slope. So if I look at something like this, you can see my slope is negative, and it's 0 at 0, and then my slope is negative if I place this kind of on the graph here. My slope is always negative, and that's what I want, except at x equals 0, my slope is 0. So slope is the value of the derivative at any point. But I don't know this function, so I can't calculate it algebraically. I just need to see from the graph the slope is negative. Right? So the value of the function at 0 is 1, so I need to make sure I put this point at 0, comma 1. And sometimes that can be a little tricky with my mouse. It doesn't want to cooperate with me. 0, 1. So I've got the point at 0, 1 that satisfies this condition. My slope at 0 is 0. So my first derivative is 0. And then I have a negative slope. Is this what it's saying? It wants positive slope. So sorry about that. I've been saying that wrong. So I don't want this function. I actually want this function because I want a positive. The slope is greater than 0. So if I move this here, I have a 0, 1. Okay, positive slope, sorry. Greater than 0. If x is less than 0 or if x is greater than 0, the slope the whole time is positive. So this would be this function. And then if you scroll to the bottom, submit your answer, it will grade it and tell you your right answer. And then show solution, it will give you the answer if you got it wrong to see the solution for what that was. And then the next question, 25C again, the graph of the derivative is given, or sorry, sketch the graph of the derivative of the functions whose graph is shown. So this is the graph of the function, and I want to know the graph of the derivative. So I know the graph of the derivative is 0 here and 0 here. So it means my derivative function, whatever function I pull on here, is going to be my blue function. So again, I have a few different choices. I wanted to pick the choice that this is a negative slope, positive slope, negative slope, positive slope. So this means the function's above the x-axis. All right, sorry. Negative means below the x-axis, above the x-axis, below the x-axis, and above the x-axis. So the only one that could possibly be is one like this. And hopefully I can get that to switch properly here. Alright, sorry, I forgot to grab, I had kind of these two here, and I want the one that starts out being negative, so it's going to be below the x-axis. So I want to actually get rid of this one and look at this one. So this, I can move this point anywhere on the graph, but where it looks like I need to move this point, this has a slope 0, so this is going to be a minimum, a maximum, and a minimum, and that's going to come in handy in chapter 4. But it has to have the derivative is your slope. So anywhere your slope's 0 means the blue function has to cross the x-axis. So that's at minus 1, 0. At x equals 0, it should be 0, and at 1, the blue function should equal 0. So moving this, it should be at 0, 0. And if I put that there, you can see I have a negative slope, right? My slope here is negative, so therefore the value of the function for the derivative is below the x-axis. Then here my slope is positive. So that means the function is going to be above the x-axis from minus 1 to 0. Here my slope is negative. Overall, it has to do with slope. The slope is negative, so from x equals 0 to x equals 1, the derivative is below the x-axis because the value of the derivative is negative throughout this region. And then from x equals 1 on, my slope is positive, so it looks something like that. And of course, you scroll down and submit your answer. Now, if you're off a little bit, it can be kind of annoying because you need to make sure that that point lines up perfectly. So we pull up, this again, just kind of looking at examples. This is the example we did. If you can kind of visualize here the slope at any point, this is a positive slope, this is a 0 slope, right? Positive, 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 0, and then if I keep thinking the tangent line at any point, it's always positive. Here, if I look at the green function, this is a negative slope, right? This is a slope at 0, this is a slope at 0, this is a slope at 0. This is a negative slope, this is a positive slope. So on your exam, I might have just the green function here, and I might say, what is this point A, B, and C, and I'll be saying the value of the function at point A, let's say at A, f prime of x at A is, and then a box, and then you have 0. So you can actually fill in greater than, less than, or equal to that box. So you can see this is a negative slope. So the derivative at that point is negative, so it's less than 0, right? And at B, the derivative is greater than 0 because it's a positive slope. And at C, the derivative equals 0 because this is a slope of 0. So it's important to be able to connect the graphs of the function or any function to the graph of a derivative. If I just look at a basic function, if I look at x squared, right? This is x squared, then the derivative is just 2x. And we know that algebraically, right? But you should see this is a negative slope. So I'm below the x-axis in this region. This is a slope of 0, so I cross the x-axis at that point. And then this is always a positive slope. So my corresponding function, f of x, this is f prime of x, right? If I had to draw the second derivative on top of this, right, that'd be constant 2. This would be f double prime of x, and that would equal 2 because the slope everywhere has a positive value of 2. The slope is positive everywhere. It's a positive slope, and it's always 2. So here's a kind of example of visually what's going on. We have the function, the first derivative, and the second derivative. And we really haven't got into graphing, second derivatives yet, but it's the derivative of the derivative. So hopefully this kind of helps us see the first thing you want to look at, or the first thing to look at, is where's the slope 0, because that's one thing we focus on in calculus. This is a 0 slope, this is a 0 slope, and this is a 0 slope. So that tells you that the derivative crosses the x-axis at x equals 1, at x equals 1, at x equals 0, and x equals minus 1. And then look, where's the slope positive? Well, the slope's positive this region and in this region. So that means my derivative function needs to be above the x-axis in those regions, and it is there. And you can see when it's negative, This is a negative slope and this is a negative slope, meaning the value of the derivative is below the x-axis there, and that one fits there. So hopefully this video is helpful. If you have any more questions, please let me know.